Nobody who has ever crossed into a black hole has come back, and physics says they never will. For much of the 20th century, physics described a predictable universe. General relativity provided the mathematical geometry to explain how stars and planets moved through space with clockwork precision. Physicist Albert Einstein was the primary architect of this incredibly orderly framework, yet his own equations contained a result he couldn't accept. They predicted points where mass compressed to an infinite density. To Einstein, this was a mathematical glitch, an absurdity that nature would never permit in reality. In 1964, a sounding rocket detected massive X-ray emissions from the binary star system Cygnus X1. The companion star was being actively consumed by something invisible and incredibly dense. The math was undeniably right. Black holes are real. Millions of them drift silently through our own Milky Way right now. We can precisely map their locations and accurately measure their mass, but our physics completely fails to explain the fate of matter once it falls into one. Approaching a black hole, the scale is difficult to process. You see a sphere of absolute darkness, warping the very light of the stars behind it. This is the event horizon. It's the boundary where gravity becomes so intense that not even light can escape. Because gravity slows time, an outside observer sees you slow to a crawl, eventually freezing perfectly still at the horizon forever. From your perspective, your watch continues to tick normally. You plunge through the boundary instantly. Immediately inside, the gravity at your feet pulls exponentially harder than the gravity at your head. You are drawn out, stretching matter atom by atom, into a continuous microscopic thread, a process known as spaghettification. Crossing the event horizon destroys the observer's body and simultaneously dismantles the geometry of space and time as we understand them. All consumed mass shrinks into a point of infinite density, the singularity. This breaks quantum mechanics, whose strict rule states unique quantum information can never be destroyed. But relativity dictates the singularity crushes everything into zero volume, wiping the information out of existence. Quantum mechanics requires the information to survive. Relativity requires it to be annihilated. The singularity is the exact location where our two greatest frameworks of reality mutually destroy each other. If we move away from the microscopic destruction at the core, we see a different perspective of the wider universe. These objects serve as cosmic anchors. Their immense gravity provides the central hub holding entire galaxies together, including our own. In 2019, humanity finally captured visual proof of this relationship. A global network of telescopes peered right up to the glowing edge of the abyss. This animation illustrates Hawking radiation. Black holes are not perfectly black. They slowly leak tiny amounts of energy back out into space. Because they radiate energy, they lose mass over time. Given trillions of years, a black hole will eventually shrink and evaporate into nothingness. When the black hole vanishes, the history of everything it consumed disappears with it. What actually happens at the singularity remains the most profound unsolved problem in all of physics. Subscribe to Stellar Abyss. The next video is already waiting for you.